Good morning, everyone. I'm Om Damani, and this is mainly the work of my PhD student Siva. So actually, he should do all the talking. I will just set the context. So just now, Dr. Reddy talked about how many soil cards have been distributed, and Professor Sen in the morning also said that the National Scheme for Soil Health card is a good beginning made, but it should not be the. I mean, it should not be the end. It should just be the beginning. But we are here to slightly question that narrative and say, is it a beginning well made, or do we have to really consider what is going on? So this is the government website. This is what the Ministry of Agriculture would like to give in the hand of every farmer. And over 2 crore soil cards have already been distributed all over the country as per the website. So just it's a printed report with all the nutrient, and based on this the fertilizer recommendation and the soil amendment requirements may be made. And so the question is, when you do such a large scale testing, how do you make sure your testing is correct? And the ministry says that in every state 1% of all the samples will be cross checked, and they will be sent to some referral laboratory and cross. Unfortunately, not at least we are not aware of any single cross testing result in public domain. If 2 crore cards have been given, then 2 lakh samples should have been cross tested, and at least that should be very surprising if they all matched very well. So this is really the context in which we were going to talk about our work. Of course, our work was not really about soil testing. So I'll briefly set the context by talking. Our goal was to coming up with a composite index to compare different farming systems, whether organic, chemical, biodynamic plus organic as presented or whatever. So we'll briefly, for half the talk, we'll just explain what this framework is, how we were doing the field application. And in that context, as we did the soil testing, so what was our experience? And we are not soil scientists, so we are just saying what we found as a user, and many of you can correct us. And what does our small scale testing tell for large scale soil health card? So essentially, this audience needs no motivation that why we should not just focus on economic, but come up with a socio-economic and environmental dimension. By composite index, we mean coming up with a single number between 0 and 1, using which just like a human development index, so that you can compare different systems. So identifying set of indicators, and so I will let Siva talk about the design of the composite index.
Good morning. So as Professor said that the main objective of our work is to come up with a holistic set of indicators, not just the yield or income, which is usually more focused. In fact, we can say that those are short-term indicators. Just every year we are just focusing upon how much is the yield and how much is the income. So we designed a framework which is stock and flow based framework. Stock and flow is usually a concept which are used in operational research. So this stock and flow framework helps us identifying the long-term variables. How a particular variable is affected over a long term. Those are the focus variables, and the stock and flow concepts help in identifying those long-term variables. So I'm not going to detail about what is our framework is all about. So as I said, it helps us identifying the long-term parameters. So to just have a brief about it, there are 2 different types of variables in this concept: stock and flow. Stock is accumulation of characteristic of a system over long term. So we are saying that we need to really focus upon those variables. And we have flow variables, and we say that positive variables needs to be taken as efficiency parameter, because I think I'm audible.
Yes,
so
recording, so that is why
You speak on the mic, it's already on. It's on.
okay, so just because of that, we are using desirable variables in terms of efficiency parameter, and undesirable variables, basically the impacts caused, as absolute terms. So this is the idea of our framework. So using this framework, we selected over 30 indicators, and we classified according to different dimensions and parameters. And one of the advantage of our framework is to come up with a proxy indicator for the indicators which are a bit difficult or complex to analyze. For example, you can take water contamination, which are caused by farming practices, very difficult to estimate because of many things. One is by estimation, lab procedure itself is complex, and second is the location of the location to estimate those indicators. For example, well may be situated within an organic farm, but that will be affected by a chemical farm which is outside the farms. So these are the complexity involved in it, and in order to estimate these parameters, we could come up with a proxy variable, proxy indicators, using our framework. And that's what this is for. A few examples for health impact of the fertilizer oil and health impact of the pesticide is measured using our methodology. We designed this pesticide impact question. So basically, as earlier we said, we are trying to come up with a single number for a better communication, basically public communication. We are trying to come up with a single number. But we are measuring various parameters which are in different units. So in order to aggregate all of them, we need to normalize it. Basically, making every dimension into a single scale. So that's what it is, normalization. That's a methodology to bring in all the parameters into a single scale, and that is done by min-max method. Second is we give different importance for different parameters. That's why weighing, and we did a hierarchical weightage method using a Delphi panel. I'll just brief about what is it about, and then aggregate it using normal mean. So this is the normalization. So min-max is basically you come up with a single, it's a function basically. You convert all the parameters from 0 to 1. So we fix the value using a reference point which is 1 and which is 0 and which is 0.5. Based upon that, you fix your parameter, your indicator value in that function and come up with that number 0 to 1. So this is how we normalize it, and it might be in different function. I think I'll not really get over it what it is. If you want to understand it a bit more, I can explain it later on. So this is how the weightage is done. So we had an expert panel where we had stakeholders, and we had more than 20 people in our group discussion in the workshop, and 6 are main called as experts. One from administrative bureaucracy, secretary of Ministry of Agriculture, and a couple of people from economics, and a couple of them from agronomy, and as well as from NGO representation. Everyone was there. So we gave weightages for all the indicators we identified, and we classified according to different dimensions. So this is the weightage. You can see the final weightage given to that, which will be accumulated to different indexes, and that will be aggregated again to come up with a one composite index, compiling all the all three dimensions. So this is the methodological part. I'll just rush through where we applied this methodology. We started with 5 different states, 30 organic and 30 chemical farmers in each state. But now we are mainly focusing on Maharashtra and Tamil Nadu with our NGOs, associated NGOs, which are facilitating our field work. So this is the final, overall result of it. Before going to the index related discussion, I'll just try to say about how the indicators have fared in different years. So I'm just giving an example of a single state, Tamil Nadu, and it is paddy. This is called radar chart. This is all showing the normalized indicator value. It starts from 0 to 1. So basically, the larger or further the points are from the center, it shows the better it is. So for example, paid out cost is always, so blue is organic and red is chemical. So organic have done better in paid out cost, net income, everything in the first year. But second year you can see that there is a small, a drop in yield, or rather I would say that there is an increase in yield in the chemical farm. So it is just over that, but still again the other parameters still remain the same. So this just another one, just to focus like fertilizer impact quotient. So you can see that there is a huge increase in fertilizer input. For example, from 16 kilograms to 33 kilograms. But still, if you see the fertilizer impact, it is not really going really low because of increase in the yield. A slight increase in the yield really makes some difference. That still the fertilizer impact quotient is remains the same in the chemical farms. So this is how the methodology works. So we are not just directly penalizing upon chemical farms just because of application of fertilizer or pesticide. So if it has a corresponding increase or impact, we still give good rating for them. So I'll just move on to the final outcome of our overall results. So we could see that really all the cases, 4 crops in Maharashtra over 2 years and 2 crops in Tamil Nadu over 3 years. The organic farms have performed better in all the cases. Almost all the cases, I would say, because you can see one place where you can just see that wheat in one particular year, Maharashtra has, chemical farm have scored better, and that is mainly because of pesticide usage in this particular farm, and this particular year has been relatively less. That's why it has scored better. And one more small observation is that the variance within, I'm sorry, I think there is some issue. The variance curve is quite higher in case of chemical farms. Though not just the scores are less, the variance within the farms, across the farmers have been quite higher in case of chemical farmers. So this is an example. So where we really want to contextualize the entire study here on the soil parameters, because the focus of the discussion is more on soil, and the soil parameters are fitting in the ecological index. So we could really see that two observations in this our studies. One is that we didn't really find much difference between organic and chemical farms in case you see really the soil parameters only. The farms which we have selected are some 3 to 5 years old organic farms, but still we didn't really see much difference between organic and chemical farms in soil parameters. That's one observation. And number two is that why over here is the difference, the organic farm is higher is because of the other parameters like soil contamination, biodiversity related parameters, it's a bit higher. So the main thing over here is the soil parameters didn't vary much between the organic and chemical farms. So this is one observation, but I'm just going to speak about the challenges or the things which we encountered during doing all this study. So that is more about the reliability of the soil samples. We could see that we took 3 composite samples in each and every plot. So out of 60 farmers, we just focused because of the complexity and the resource involved in the soil analysis. We selected just 20 farmers, 10 organic and 10 chemical farmers, and we took 3 composite samples for each and every farmer, and in only one crop plot. So cotton crop. Basically, our focus was more on the cotton crop. So one is the non-heterogeneity or non-homogeneity of the parameters within the same farm. And number 2 is the measuring, the conditions in the laboratory. So how a researcher is conducting the experiment, the equipments. So a lot of things involved, and everything is giving some sort of error range, and we are unsure how we can really trust a final results which we come up with. And again, another one is the laboratory. One we did it in our own laboratory, and we gave some samples outside also the experiments. So how it varied. So that I'll just come how it is. So if you see this one particular parameter, soil organic carbon, you can see this is the range. This is a sample taken from the same plot, which is not. Yeah, I'll just cover it fast. So it's basically the same plot, triplicates of samples, and each and every reading is a composite samples reading. Estimation. So you can see the variability within the plot. In case of organic organic carbon is relatively okay. It's like some cases it's like 50% more than one particular place. And if you see the nitrogen, it's also similar to that, a maximum of 50% variation. But if you come to the variables parameters like phosphorus, you could see 4 to 5%, 5-fold increase in the parameters within the same farm. So, and potassium, similarly, it's like you can see some differences, 30% increase within the same farm. And pH is relatively decent. Here you can see conductivity is like double the fold increase in the same farm. So, this is one thing which we are really curious and unsure, that we are coming up with the soil scheme where we take only one sample for 2.5 hectare, and we are here estimating soil parameters within 2 acres of plot, and this much of variation is there in each and every parameters. So how we go about it? Is it really making any work? So that is one within the plot heterogeneity. And another issue is the lab dependent variables. So this is the same sample, same time. One lab is giving 0.6 and we are coming up with a number of 0.4. So there is a 50 to 60% difference in the same parameter, same time, same sample in different labs. So what we really get out of it? What is the reliability? So similarly, different things, different other parameters. So that's what. So basically, we are not really the people soil scientists. We are not really working on these parameters, but we are just curious and want to really raise this concern and issue in this platform that this much of sample is being collected. We are hardly collecting 60 samples and analyzing 60 samples. Here, lakhs and lakhs of soil samples are being collected, and different variety of labs is being used to analyze it. and hardly one sample for 2.5 hectares of land, whereas ours is less than 2 acres of land, like 1/5 of the size what we are analyzing, and that much of variability in. So, I mean, what really we get out of it? I mean, again, a lot of other parameters like what is the crop cultivated in the farm and what is the nutrient applied in the last farming, crop cultivated. All those parameters are there. So, what we really going about the soil card? That's the main question we really want to put it over here. And yeah, so is there, we need to really rethink about our approach for the soil card? Is it how to really, standardize it, or what is the purpose of it, or we really need to focus on a particular parameters like soil organic carbon, which should be rechecked and worked upon? So that's the main thing we want to really rise over it. And for just to add about it, I was there in this agricultural science congress in the last 2 days, and there were studies where they have been trying to evaluate the soil card scheme, and I could really see that it was done by IFPRI, International Food and Policy Research Institute, and they have been saying that the farmers haven't really built trust on the soil card by itself. So what we can really do about it? I mean, it's not their fault. I think there are a lot of loopholes within the system itself. So how we can really go about it? What can be done about it? That's the main question we would like to do over here. Thank you. Thanks,
the question about your presentation, I'm not sure of what kind of prices you use when you compare organic versus chemical. If you are using, let's say, market prices, there will be bias on one side. If you are using imputed, let's say, shadow prices, there will be a bias on the other side. So the price aspect is not very clear. I completely agree with your observation on soil health card. Dr. Sen mentioned is the program is taken now. In our area, I live in Madhya Pradesh. The experience is very, very miserable because all kinds of analysis is done, results not unclear. Last question is to
this by the costing thing. So we have detailed data split of what is the paid out cost, what is the self cost and everything, and we have methodology for each and every indicator. And for example, to just cite one, for riskiness case, we have accounted for self-paid in cost, self-labor cost as well as self-borne input cost. Everything is accounted in case of riskiness. But when it comes to this financial resources as an indicator by itself, we have just used paid out cost alone as an indicator over there. And that's one thing. One more thing, that availability of organic manure, that's definitely, we also, with my field work related thing, definitely that's been seen as a major problem. In fact, we do assume, think that why there isn't much change in the parameters, soil parameters, it's because, for example, if you see the recommended dosage as such for organic inputs, it's like somewhere about 20-25 tons per hectare. But whatever has been applied is hardly 4 to 6 ton hectare at max. So there is a huge gap between what is being applied and what is supposed to be applied in case of organic thing. So there is definitely a huge boost to be given for the production and availability and access of the organic inputs. So that's what I would.
Just to add, we have just presented one set of number. The important point is that we have a tool and an Excel-based system where you can change the assumptions that you want. See, even the weightages that have been given is given by some expert panel. But if you have a different perspective, then you can just change the number that this parameter is more important, this is less important, and then it will give you the result. So similarly, whichever element you want to put paid out or paid in, whatever, all the data is there. The references are also the issue of what is the average that you should take, state average, district average, national average. So this is a customized tool with if anybody you want to use, and also a lot of concerns expressed here are, all those indicators are present. So in that sense, I would request if anybody else wants to use, we'll be very happy to see how customers